Okay, we're going to finish up sharpening up a 100-year-old pair of skates, Jackson Haines. These particular ones have a wedge shape through here. It's thicker than here. Also, the blade is such it's thin the width to max and back down again. I believe you call it a parabolic. And these are fixtured down here where it has actually a flat area to clamp to. And similar on a modern blade here, this is a gold seal. This is thin here, thick, thin. It gives kind of a different type of reflection. And so these are clamped on these two areas. If you clamp here, you're going to have an issue with the tabletop machine or sparks or whatever. Normally you can't do this with the sparks, but on a tabletop machine you need to clamp on these two areas here and here, which is flat. This is parallel here. That's what I've done in this particular skate. So I'm going to go ahead and fire this up and do a couple passes. For that, I'm going to go ahead and do the radius curvature. This is on a 1/2 inch. Before I do that, I'm going to put this on here to collect the dust. Trued the wheel up. This is the pivot point. This is the eccentric, and this is where you adjust the radius of hollow on the ice machine here. Incredible edger. Got the dust shield out of the way. This is hooked up to a shop vac. I'll run this without the shop vac. Hear me talk a little bit longer. What you would never want to do on a figure skate is on this back area, you don't want to turn this down. So the radius from here to here is normally one specific radius, maybe anywhere between 8 to 10 feet. And then it transitions, even on this old skate. So when you go through and do the final cut, you don't want to push harder onto here. Sometimes you get skates where somebody's gone through and pushed down too hard, like on here. This radius on this gold seal from here to about over here is 1, and then there's a different radius. Some skates actually, in figure skates, have 3 radii. And this particular one from this flat point to here is what you call the non-skatable zone. So from here to here, it doesn't touch the ice. So you don't really have to go all the way down to the toe pick. This is where you spin around on. And this old skate here, I have no idea what the original toe pick was. It has a kind of a crosshatch, but that's a 100-year-old blade. So I'm going to do a couple more passes here without the grinding noise. And I've got this on the carriage. You can see the sparks go out straight. So you've got dust coming out this way. If I kick the blower on, what you can do is go through and mark this with a magic marker to see where you're cutting. This particular one, I put a straight edge across here to see if this is flat. And because this is not a parallel cross section, you can't, if you put a square on here, you have to compare the two sides. So if you put a square on here, you have to check the gap that's on this side versus the gap that's on this side. If you put a bat gauge on here, this is not parallel, so this is not a good reference to use. So on figure skates, you got to be aware that on higher end skates or sometimes older ones, you've got one that's not a normal type blade. So this particular one looks like this. It's wedge shaped. So when you put the square on here, you're looking for the gap, equal gap that's on either side. Or you can put a very long straight edge like this. Like an old, I've got a hockey blade you can put on here. And you can see that if it's tilted this way or this way, to adjust the carriage on the credible edge or up and down. So this is all dialed in. This is a particular, one of the strangest blades I've ever sharpened. Again, this is, the width here is very thin. This gets to be thick. And this is moderate. So this goes one width, gets to be max width, and gets smaller. And then the cross section through this way is all wedge shaped. So I had to goof around to get that to hook in there.